Okay, this video is now lecture 8, AP Physics, lecture 8.7.2, which is part 2 of the introduction to electrical circuits. And this will feature voltmeters and ammeters. So on our current sheet here, I'll let you read this here, and we'll want to construct this circuit here. So using the one that we already have over here, let's go ahead and let's let it go here. Let's remove that. So here we have a voltmeter, which is right here. It measures voltage, and we'll put it right here. And so in real life, we would have used a multimeter, but since this is virtual, this will measure voltage. So we'll put one electrode here like so to measure that, and we will measure this right here. And notice it says 9 volts. Okay. Now, if I was to go right here and switch them, let's say, right, it'll say minus 9 volts. So it just depends on how you put the terminals here. If this is positive and it's coming right here, it's usually a good idea to put positive so it lines up with the positive terminal here, and we'll go ahead and measure this, and this is now 9 volts. So go ahead and copy and paste this into the screenshot there, and I will go ahead and pause. I forgot to add too, so this is the battery over here. So I'm going to put this right here. Let's try to measure the voltage across the battery. Let's see what that is. Let me go ahead and go here, and we'll go here, and I will go here. So the voltage of the battery is actually 9 volts. Okay, so the battery is 9 volts, and this here is also going to be 9 volts. And we'll talk about why this is in a upcoming in our next lecture that we meet again. I'll hit pause again and let you screenshot that. And I forgot to add that when we measure voltage, the voltage this is called in parallel. So we are in parallel. So when we measure across this here, measuring voltage is in parallel. So that means that as electrons come through here, they have a path. They can go this way, or they can go this way here. But this is called measuring in parallel. Let me hit pause again. The next thing we want to do is use an ammeter, which measures current flow. So here is our ammeter right here. Now this one here has to be in series. So if I look over here, I see that conventional flow goes like this. And notice here that it's just one path. This is called series. So in order to do series, let's go ahead and let's be careful here. Let's open the switch up like this. And I want to add this in series. So we could possibly, let's say, I don't know, let's go ahead, maybe let's cut here. And I'm going to put this right here. So let's kind of go right here. We'll put that right here, and I will go ahead and put that there. So now it is in series. So if I go ahead and close it now, you see the current flow now goes through the actual ammeter. So this ammeter is actually part of the circuit. And notice here it measures 0.9 amps. So go ahead and screenshot this and add it into your screenshot and insert it into the box here as well. All right, so here we have our voltage here, our voltmeters here. So I'm going to measure this here. We'll do that, measure the voltage. So now, as it's set up now, I can measure the voltage and the current simultaneously. This is in parallel, and this is in series here. So let's take a look at some questions down here. Here's 12.22. Which circuit diagram below correctly shows the connection of ammeter A and voltmeter B to measure the current through and the potential difference across resistor R? So this is resistor R. And let's go ahead and try to construct the correct diagram using resistor. And I'll go ahead and pause and let you guys go ahead and do that. Okay, so let's try to see which answer works correctly here. So for this one here, hopefully you selected A, okay, or maybe not A. So actually it's not A, let's double check here. And so it should be number 4 here. So let's take a quick look here and see how we might do that. Okay. So I'll go ahead and do reset here. So start fresh here. And I'm gonna go ahead and do a battery here. And let me go ahead and do schematic. So here's the battery here, like so. And let's go ahead and do a wire. Okay, kind of make it make it kind of big if you want to. Now I need a resistor. So I'm gonna put a resistor here like so. So there's a resistor here. And let's go ahead, and I don't see a switch here. So let's go ahead and do a wire here like so. And let's connect it. All right, so here's the circuit. And we want conventional flow, which is right here. Okay, going to the circuit. So I want to measure the voltage. So to measure the voltage here, I'll use the voltmeter here. And we'll go ahead and put this here, and we'll put that there, and it measures 9 volts. Now, however, I have to put the ammeter in series. Okay, so so we can probably put the ammeter, which is right here. We want to put it somewhere before it hits the circuit here, or this resistor. So let's go ahead and focus on this. Let's cut that, and let's go ahead and put this here like so, and put that there. And now we have current flow. The ammeter is in series, measuring conventional flow here is measuring 0.9 amps. And we have the voltage across the resistor here measuring 9 volts. So it looks like number 4 is correct. So go ahead and screenshot this and plug it into this box, screenshot it and paste it into this box here. And let me hit pause here. Okay, we're now on question 12.23. A student uses a voltmeter to measure the potential difference across a resistor to obtain a correct reading. The student must connect the voltmeter how? Okay, it should be in parallel with the resistor. Okay. 12.24. Which statement about ammeters and voltmeters is correct? We should have the internal resistance of both meters should be low. Okay, it seems kind of like intuitively that seems correct. Okay, but that is right. And finally, 12.25, compared to the resistance of the circuit being measured, the internal resistance of a voltmeter is designed to be very high so that the meter will draw little current from the circuit. All right, so that concludes part 2. And go ahead and stop the video, and I'll see you for the next discussion a little bit later this week.